Hi, I'm Claire Connor, Principal Pre-Sales Consultant at Geniez.
My name's Kai, I'm a Senior Software Developer at Geniez.
We're here at Share this week in Pittsburgh, and we've been having some very interesting conversations with Mainframe clients.
Recently there's been a lot of news about the new frontier models like ChatGPT 5.6, Astra, Fable, Mythos, and the implications they have for both the mainframe and distributors. And it might be cool to just discuss how we feel that may impact the industry.
Well, we've definitely heard our clients saying that the amount of vulnerabilities that are being found both on their systems but also coming from the software vendors themselves has been significantly increased than previously. We had examples that vendor CVEs and patches are being released at an amount probably 10 times to what they were being released 12 months ago. And this is creating a lot of issues for the operations teams, mainframe teams that are being asked to implement them, validate them.
Do you think there's a risk of there being such a massive backlog of CVEs, vendor patches, etc., that they're going to struggle to stay on top of them and they're going to forever be battling against the backlog?
Yeah, absolutely. There's always been a backlog of patches and CVEs that need addressing. And it's no different now than it was 12 months ago, except that these are coming out and they are high risk, high severity, critical security patches, and the risk of not implementing them is significant. The cycle that organizations have historically adopted could be 6, 12, 18-month patching cycle, and really waiting until someone else finds an issue with it or experiences that vulnerability. Now, that's no longer sustainable, and these teams are being asked to validate and implement these patches no longer in an 18-month time period, but in a 1-month time period, or in some cases 2 weeks, 1 week. We have heard rumors of 3 days, which it's not just the impact of how quickly they need to do that, but the process will have to adapt to accommodate that.
So yeah, with the current process, I suppose there's the sort of understanding that the CVE exists, then getting information about the CVE or the vulnerability, looking into what the patch involves, working out the test plan for the patch, applying the patch, and then testing that the patch has done what it needed to do. And do you think that's somewhere that AI today could help?
Well, yeah, I mean, absolutely. One of the things there is you get that patch from your vendor. They say, hey, this is a critical security patch, and if you had 18 months as the patch cycle for it, maybe with a critical one it's not quite as long as that. Maybe you still got a month to validate it, but you have to find out where in your environment it impacts. Are you actually using the feature that creates this vulnerability? Knowing how many instances you have to apply of it. Is it going to affect anything else in your system when you do apply it? A lot of shops will have it that it needs to sit in test or QA for at least a certain period of time before they're allowed to patch into production. With them now being such critical security issues, you no longer have the time to wait to validate that it's not going to cause an issue that you would have done before. Now, what that means is you have to trust your vendor that they are releasing quality PTFs, that patch you're applying to fix the critical security issue is not going to cause more issues itself, which is not necessarily something mainframe teams are used to doing. giving that level of trust to another party. But it kind of has to be done when the speed that you're being asked to implement these is that much higher.
But I suppose the vendors are in the same position where they're finding out about CVEs and patches through probably internal testing, things like that. And that means they need to put out a patch as quickly as possible. So potentially they're not testing it as much as they would like. So it's like a cat and mouse of having the patch available, testing it enough, and it's trickling all the way down from vendors to clients to everyday users.
Yeah, absolutely. And from what we've heard as well, the amount of detail contained within the PTFs that are being released is significantly lower than it maybe was 12 months ago. So you're right. The vendors are releasing these patches because they need to be addressed, and they've built the fix for it, but maybe they haven't spent as much time writing the documentation, the write-up, actually, like everything else that is going to be impacted by applying this fix. So it's one of those things where when we see a problem like that, we think that AI can help, right?
Yeah, so I suppose with AI, it's going to help with automating, potentially reading the patch and understanding what it may involve in terms of the systems it'll affect, how long it might take to implement, the risks of implementing it, and being able to summarize that for consumption without requiring an enormous amount of man hours, requiring an error-prone process of manually checking everything, and getting to, at the end of the day, getting the patch applied quicker with more confidence.
Yeah, so when we were having this particular conversation with one of our clients, there was a discussion around how would we be able to automate that. Want to share your thoughts on that?
So automation is interesting because it needs to be done in a way that's targeted. You don't want to automate everything all at once. You need to trust the automation that you build, and you also need to ensure that the automation is fit for purpose. So specifically in the use case of CVEs and patch management, I think automation's a really interesting use case. No one wants to have a backlog of 1 million different CVEs that need applying. And of course, there's risk associated with that as well. If you're a business and you've been made aware of a vulnerability, you have an obligation to apply that patch in a certain time frame, depending on the severity. Of course, the most critical patches need to be applied as quickly as possible. Should they not be applied and that CVE is used in an attack, I know there's massive implications across the board for, especially in the financial industry, which of course Z is heavily involved with, and healthcare. So I feel like automation is an excellent use case for this initial sort of automation using AI and getting them patches applied as quickly as possible.
Yeah, absolutely. And in regulated industries, it is particularly important. But even in unregulated ones, the risk of like reputational damage, if it's aware that you know that there's a risk and you've chosen not to apply it in a reasonable time frame, it can cause a lot of reputational damage anyway. But when it comes to that automation, we assume, yes, we've decided we're going to use some automation, and we're Geniez. We want to use the Geniez framework to achieve that. Can I give us some examples, especially in the early stages? I've got this giant list of CVEs, patches that I've been told by my vendor is critical. How are we now going to go about addressing this?
So initially you can fetch the information about the patch from the vendor, and once you've got that, you can put that into the Genie with some maybe a bit of extra context around it to help explain, especially if it's one of the more recent patches we've heard from vendors, where there may not be as much critical detail as needed. And then you can send that prompt off on its way, and by using the Geniez framework, we can go through, we could look at the actual context on the system, log in with the users that the actual business uses, look at the data sets, the log stream, the SMF records, using a wide variety of the specialist Genies that we've built, the SMGs. We can fetch all that data, collect it, reason over it. If anything's not clear, maybe send some more SMGs on their way to sort of probe deeper into the system, and then come back with a holistic overview of, is the patch applicable? Because initially it may not even be applicable to your specific system or LPARs. You can then determine what the risk is of the patch, how easily accessed is it? Is it something that is critical and it's easily, it could easily be used by someone in an attack? And then how could you mitigate it? How do you apply the patch? What does that involve? Is there any risk of downtime? Geniez can help you work all of that out with that connection to ZOS and that live data stream.
Yeah, absolutely. I think being able to validate to start with that this high severity critical PTF actually applies to you, that's a really simple first step, and you may well be able to disregard an element of them for features and capabilities that you don't use. And then knowing exactly where in the system, what's the downstream impact of applying this. And I do think that you said validating how applying that fix is going to work. Do you need to bring the system down? Do you need to recycle resources? Do you need to do an IPL? How impactful is applying that PTF? So being able to do that initial validation once you've got the patch data from the vendor, I think is great. Then, is there anything we can do afterwards?
Yeah, the Geniez framework has some great features to be able to do this patch management and install across a huge number of LPARs all at once. So say you've got a patch you need to apply, you can create a command in the Geniez UI. It's really simple. As part of that command, you can provide some variables, some parameters that can be passed in. You can set what LPARs that should run on, and then you can even set it as a scheduled cron job. Maybe you also want to check daily for any new patches that are available, or check if there's any other problems with the system. That's all possible with routines. But yeah, for patch management, set that up, have it run, apply the patch. You'll even get summary at the end. The boxes will go green or red depending on if it was successful, and there'll be a sort of short AI summary of what the actual process looked like. And in fact, under the Geniez hood, everything is a conversation, so you can actually go to that routine, check it out, see what happened, look into the SMGs themselves, and really drill down into the process that happened.
Yeah, no, absolutely. And the example, like, we're applying a patch, and yeah, maybe applying it once only takes 20 minutes, half an hour, but if you're actually implementing that across all of your systems in your whole environment, it can take a lot longer, even though the process of doing it is pretty much identical. Yeah. So being able to set it up once and have it apply it across the board while you get on doing the next patch means you can get through them a lot quicker.
Yeah, and I think with the rise of these frontier class LLM models, this problem's only going to get worse.
Well, yeah, absolutely. So just to touch on that, with Project Glasswing in particular, Anthropic and OpenAI agreed to withhold the release date of these models, particularly the likes of Mythos, GPT Cyber, and a handful of others as they've developed, to give these large organizations a chance to catch up with the security vulnerabilities that they're going to expose. Now that time frame that they've agreed to withhold them is running out. I believe we've got about 2 months left, which really does put the pressure on Mainframe clients, all clients really, to have worked towards addressing this risk. Because in 2 months' time, these models are going to come out, and there are no risks, which is why it's been withheld so far.
Yeah, I mean, it's scary, but it does sound like there are tools like Geniez out there to help with this, to help the patching process and a lot more operations. But yeah, great chat.